Okay, calculus, let's wrap up 15.2. Find the work done by the force field f of x, y, z equals negative 1/2 xi minus 1/2 yj plus 1/4 k on a particle as it moves along the helix given by r of t equals cosine ti plus sine tj plus tk from the point 1, 0, 0 to negative 1, 0, 3 pi as shown to the right. Okay, well sometimes it gives things to you straight up. So if we have tk and k is going from 0 to 3 pi, it looks like 0 is less than or equal to t is less than or equal to 3 pi should be what we're going with. Judging by how things are working, we already know that what r of t is. We know x is cosine t, y is sine t, and z is t. So let's find r prime of t. It looks like the derivative negative sine ti plus cosine tj plus k. What's our function in terms of t? When we substitute t in, we get negative 1/2 cosine t I minus 1/2 sine tj plus 1/4 k still. I'm doing the dot product here of these two, so I get negative times negative is positive. 1/2 sine t cosine ti. Oh, no I. Dot product. Minus 1/2 sine t cosine t plus 1/4. So these two cancel. So it's the integral from 0 to 3 pi, and the only thing that's left is 1/4 dt. Integral of that is 1/4 t from 0 to 3 pi. Just plug in. It's 3 pi over 4. That's the work done. Now, a second commonly used form of line integrals is derived from the vector field notation used in the preceding section. If f is a vector field of the form mi plus nj and c is given by x of ti plus y of tj, then f dot dr is often written as mdx plus ndy. This differential form can be extended to 3 variables as well. So it's over here on the right. Because it's mi plus nj times the derivatives, so it's m times dx dt plus n times dy dt, or mdx plus ndy. So how's this going to work in a problem? Let C be the circle of radius 3 defined by the function r of t equals 3 cosine ti plus 3 sine tj from 0 to 2 pi. Evaluate y cubed dx plus x cubed plus 3xy squared dy. Okay, what's r prime of t? Negative 3 sine ti plus 3 cosine tj. X is 3 cosine t, y 3 sine t. Okay, so when I sub these in to their respective pieces, this is now going to become our 2 vectors here. I'm going to write them in vector form. Y cubed is 3 cubed is 27 sine cubed t. My second term, though, becomes 27 cosine cubed t plus 81 cosine t sine squared t. And this, of course, is dot product with the derivative, which is this thing, negative 3 sine ti, 3 cosine tj. We don't need the I and j for this form. So when I do this product, I get the integral from 0 to 2 pi. 27 times 3 is negative 81 sine to the 4th t. The second product, we get plus 81 cosine to the 4th t plus, it looks like 243 cosine squared t sine squared t. So let's see if we can convert everything to one term. I'm going to go all to cosine. So sine to the fourth is 1 minus cosine squared plus 81 cosine to the fourth t plus 243 cosine squared t times 1 minus cosine squared t. So when I expand, it's become negative 81. So we plus 162 cosine squared t minus 81 cosine to the fourth t plus 81 cosine to the fourth t. This is going to become plus 243 cosine squared t minus 243 cosine to the fourth t. Okay, so let's combine our like terms. These two are gone. So it looks like we have negative 243 cosine to the fourth t plus 405 cosine squared t minus 81. Just going to factor out the 81, the negative 81 to be precise. It's 3 cosine to the fourth t plus 5 cosine squared t, or minus 5 cosine squared t plus 1. Now, in order to integrate this, I have to do power reduction. So this is 3 times 1 plus cosine 2t over 2 squared minus 5 times 1 plus cosine 2t over 2 plus 1. If I expand that, this is negative 81. I'm going to bring the over 2's out, so this is 3/4. And then just multiply across the top, 1 plus 2 cosine 2t plus cosine squared 2t minus 5 halves times 1 plus cosine 2t plus 1. I have to power reduce this part again, but I should be able to combine other things together. So I'm going to leave this 3/4 cosine squared 2t. Combine my other terms. We have 3/4 times 2, so 3 halves minus 5 halves cosine 2t. It should be minus cosine 2t. We have 3/4 minus 5 halves plus 1. So that's 7/4 minus 5 halves, or 7/4 minus 10/4, so it should be minus 3/4. And then we will power reduce this again. This is now 1 plus cosine of 4t over 2. I'll bring it up over here. Okay, so we have negative 81 times the integral from 0 to 2 pi. This is now 3/8 minus 3/4 will be negative 3/8. We have a 3/8 cosine 4t minus cosine 2t minus 3/8. Now we integrate. It's negative 81. This becomes times the integral of cosine 4t would be sine of 4t divided by 4. So this should be 3/32 sine of 4t minus 1/2 sine of 2t minus 3/8 t, evaluated from 0 to 2 pi. Now the one thing about sine of both 2t and 4t at 2 pi is it's 0. So really we have negative 81 and just times negative 3/8 times 2 pi, which is 243/8 times 2 pi, or 243 pi over 4. And that is the evaluation of this integral. And that is all for 15.2.